Hello. Today I am going to discuss the second session of dual nature of matter. The term which is going to discuss is photoelectric effect. Before going to discuss this, some of the terms which is discussed in introduction part, one is called Planck's law of radiation, the second one is photon and its properties. Repeat this. Planck's law states atoms of a black body behaves like harmonic oscillators. These harmonic oscillators will have discrete energy packets. These energy packets are called photon. Energy of photon is given by E is equal to nh nu, where n is integer, h is Planck's constant, nu be the frequency of radiation. The second one is the wavelength of the photon. Lambda is equal to h by p, h is Planck's constant, p be the momentum of a photon, lambda be the wavelength of photon. The second one I am going to recap. This is in a dual nature of matter is black body, a body which absorbs all the radiations which are incident on it. The third one, electron emission. It is the emission of electrons from the metal surface. When light of suitable frequency is incident on the metal surface, the topic is called photoelectric emission, because there are four types of electron emission present. Electron emission means the process of emission of electrons from the metal surface. And there are four types of electron emission present: photoelectric emission, thermionic emission, field emission, secondary emission. The thermionic emission means the emission of electrons from the metal surface by heat the metal surface. The second one, photoelectric emission, the emission of electrons from the metal surface when light of suitable frequency is incident on the metal surface. The emitted electrons are called photoelectrons, current generated, and that is called photocurrent. Third one, secondary emission, the emission of electrons from the metal surface by bombarding high speed particles. Field emission, fourth one, the emission of electrons from the metal surface by the application of strong electric field, and it is also called cold cathode emission because emission of electrons takes place comparatively low temperature. Then using this idea and dual nature of radiation, the dual nature of radiation means light which explains all the phenomena. What are the phenomena? It explains photoelectric effect, it explains Compton effect, it explains Raman effect, it explains interference, diffraction and polarization. The sum of the phenomena like photoelectric effect, Compton effect, etc. are explained by considering light is a particle. Similarly, some other phenomena like interference of light, diffraction, polarization, etc. are explained by considering light is a wave. But light explains all the phenomena, therefore it shows both the nature called wave nature as well as particle nature called dual nature of light. And the wavelength of the photon, wavelength of the light or wavelength of radiation is given by lambda is equal to h by p. H is the Planck's constant, p be the momentum. So this is the topic which is discussed in the previous class. Now today I am going to discuss photoelectric effect. This is one of the type of electron emission and experimental study of photoelectric effect, experimental results of photoelectric effect, then Einstein's explanation of photoelectric effect, etc. Photoelectric effect, the light of suitable frequency or wavelength is incident on a metal surface. The electrons are emitted from the metal surface. This phenomena is called photoelectric effect and it was discovered by Heinrich Rudolf Hertz in 1887. The emitted electrons are called photoelectrons. Current generated is called photocurrent. Then experimental study of photoelectric effect. It consists of evacuated glass bulb which has two electrodes, cathode and anode. The cathode is connected to the negative terminal of the battery. Anode is connected to the positive terminal of the battery through ammeter. This glass bulb has a side tube provided with quartz window through which radiation enters. As radiation enters on the cathode, the photoelectrons are emitted, which moves towards anode, current generate, that is recorded by microammeter or ammeter. So current generates. So the resulting setup can be used to study the dependence of photoelectric current on the following factors. One, the frequency of the incident radiation. Second one, potential differences between cathode and anode. The nature of photoemission surface. Intensity of the incident radiation. Then, what are the results of photoelectric effect? One, results, there are four main results. One, photoelectric emission is instantaneous process. The meaning of this is, as soon as photon or radiation falls on cathode, immediately photoelectrons are emitted. The time difference between the emitted electrons and the radiation incident on the cathode is 10 power minus 9 seconds. The second result is, for every metal surface, there is a minimum frequency of the incident radiation below which photoelectrons are not emitted. That frequency is called threshold frequency. Corresponding wavelength is called threshold wavelength. The meaning of threshold wavelength is the maximum wavelength of the incident radiation above which photoelectrons are not emitted. Then result number 3, if the frequency of the incident radiation is greater than threshold frequency, the photoelectric current generate, which is directly proportional to the intensity of the incident radiation. If a graph is drawn by taking strength of the current against intensity of incident radiation, the graph is a straight line passing through the origin. Result number 4, if the frequency of the incident radiation greater than threshold frequency, the maximum kinetic energy of the photoelectron increases by increasing the frequency of incident radiation. It is independent of the intensity of incident radiation. So again, a graph is drawn by taking kinetic energy of photoelectron along y-axis, the frequency of incident radiation along x-axis. Again, it is a straight line, but it doesn't pass through the origin because there is some gap in the graph which shows that gap the photoelectrons are not emitted, because photoelectrons are emitted only when the frequency of the incident radiation should be greater than the threshold frequency. If the frequency of the incident radiation is less than threshold frequency, photoelectrons are not emitted. Then using this idea, I want to discuss about Einstein's photoelectric equation. This is a theoretical equation because we discussed when light of suitable frequency is incident on metal surface, photoelectrons are emitted. The photoelectrons are emitted only when its energy is greater than the energy of the electron present in a metal, in an atom of a metal. So that is discussed according to Albert Einstein's photoelectric equation. According to Einstein, when a photon of energy h nu is incident on an atom of a metal, the free electron of an atom absorbs energy, so its energy increases. When this energy is sufficient to overcome the surface force, free electrons are emitted from the metal surface. The minimum energy required to eject the electrons from the metal surface is called work function. Excess energies occur in the form of kinetic energy of photoelectron. So according to Einstein's explanation, the energy of incident radiation or incident photon is equal to photoelectric work function plus maximum kinetic energy of photoelectron. Implies the maximum kinetic energy of emitted electron is equal to energy of incident radiation minus means difference and photoelectric work function, and is given by the equation kinetic energy maxima is equal to h nu minus phi. It obeys the law of conservation of energy. Then what are the results of Einstein's equation? Einstein's equation mentioned above satisfactorily explains experimental observations on photoelectric emission as follows. 1. Again, it is the collision between the photon and an electron, and it is treated as the collision between the two microparticles such that photoelectron emission is instantaneous process. The result number 2, for a fixed light frequency nu, an increase in light intensity means more photons and more photoelectrons per second are emitted, although the kinetic energy remains unchanged. The meaning of this is, when a photon is incident on the atom of a metal, means it is incident on the cathode, the frequency is greater than threshold frequency, the photoelectric current generate, which is directly proportional to the intensity of incident radiation. If the frequency is greater than threshold frequency, the extra energies occur in the form of kinetic energy of photoelectrons. If kinetic energy is equal to 0, then Einstein's photoelectric equation becomes nu naught is equal to pi by h, and nu naught is called the threshold frequency, pi be the photoelectric work function, h is Planck's constant. Frequency less than threshold frequency, the photoelectrons, the kinetic energy is negative, that means photoelectrons are not emitted.